Hello again. This is Rusty, aka William Robinson, aka Dr. Robinson, and I am the Blues Doctor. And this is my podcast, The Blues Doctor Recommends, and we're glad you're here. We are in our New Orleans office this weekend for Thanksgiving. We've traveled between Orange Beach and New Orleans to see most of our kids at the same time, and we've had a wonderful time. Unfortunately, as you see, our Tulane football team has had a mixed blessing this weekend. We won the football game over Charlotte last night, 27 to nothing. But this morning it was announced that we've lost our coach. That's right, Coach John Sumrall, who has led Tulane to a 10-2 record this year, was poached basically by the University of Florida football team. So Coach Sumrall is going to Gainesville next season. It is unclear yet as whether he will be coaching the Tulane team for the conference championship game, which is next weekend, and whether he would be coaching Tulane in the college football playoffs, assuming they make that. So we'll have to see. Any rate, go ahead and sit back and share and make comments and hit the bell and subscribe and all of those things, and we'll go ahead and get started. Working on the calendar this week has been fun for me because it's got kind of a Memphis motif going on. Most of you know that Memphis is my hometown, and Memphis music has been a huge influence on me. Any rate, two great Memphis musicians were born on the same day, which is November 24th, 1941. The first is Donald Duck Dunn, the bassist, songwriter, producer, best known for his time with Booker T and the MGs, the Blues Brothers, and many others. The second is Wayne Jackson, a trumpeter with the great band the Marqués, one of the best soul bands ever, and a session musician for Stax Recording Studio in Memphis. He teamed with saxophonist Andrew Love to form the legendary Memphis Horns, who went on to play with everybody from Al Green to Jimmy Buffett. Donald Duck Dunn was born in Memphis and went to Messick High School, along with a guitar player friend of his named Steve Cropper. Some of the songs they recorded include Hold On, I'm Coming by Sam and Dave, Born Under a Bad Sign by Albert King, and lots of others. He had something of a career renaissance with the Blues Brothers, which became a Saturday Night Live sketch, and then a movie in 1980. And that gave him mainstream recognition outside of the R&B and Memphis communities. He mostly played Fender precision basses and Ampeg amplifiers. Duck died in his sleep in 2012 while he was on the road. He was actually in a hotel after a series of performances in Japan. Donald Duck Dunn has been ranked among the greatest bass players in the rock and roll era, and I would agree. Wayne Jackson was born in West Memphis, Arkansas. He crossed the river to Memphis to work as a session man at Stax Studios, and it was there that he met and began working with Andrew Love to create the Memphis Horns. In their years at Stax, they recorded with Otis Redding, Sam and Dave, and many others. They left Stax in the 1970s to go freelance and worked with Elvis Presley, Neil Diamond. They toured with the Doobie Brothers and with Robert Cray, among many others. Wayne died in Memphis from heart disease in 2016. It's been argued many times that the Memphis Horns were the greatest horn section of all time, certainly for soul, R&B, blues, etc. And I would agree with that one also. R.I.P. to both Donald Duck Dunn and Wayne Jackson. We're going to talk about a little basic science or a little basic research in the medicine segment this week, particularly what's called CRISPR, or CRISPR, and that's gene therapy for cancer. And I'll explain that in detail here. You know, ever since scientists realized that the ultimate cause of cancer is that one or more changes that occur at the molecular level of the DNA, they've somehow been searching for an easy way to correct those changes, or, in other words, to somehow manipulate DNA and thereby correct or override the changes responsible for specific cancers. Although several methods of genetic manipulation or gene editing have been developed over the years, none has really proven to be practical. I've even done some of it myself. And while we had some interesting results, we never found a way to make it expandable to use on a commercial basis. For gene editing to be successful in treating cancer, The technology behind it has got to be quick, it's got to be easy, and it's got to be relatively cheap, or else it's not workable. But we may have found that technology now in something referred to as CRISPR. As I said, CRISPR is a gene editing tool that can potentially alter the DNA of human cells like a very precise scalpel almost. The first reports of this new tool were published in 2013, and they've proven to be very intriguing. There are many different trials or studies going on currently using CRISPR, including a few human trials. The basic concept behind CRISPR was inspired by nature. We've known for some time that bacteria have their own internal defense system against attackers like viruses. To protect themselves from being invaded by viruses, certain bacteria capture snippets of the intruder's DNA and store them away as segments called CRISPRs. Again, CRISPRs, that's clustered, regularly interspersed, short palindromic repeats. You got that? Okay, anyway, if that virus tries to attack, then again, those DNA segments turned into short pieces of identical RNA work with an enzyme present in those bacteria called Cas, which will find and slice up the DNA of the invading virus. And it didn't take long for scientists to realize that it had the makings of a very versatile gene editing tool. Within a few years, the technique had successfully been adapted to edit virtually any segment of DNA, first in the cells of other microbes, and then in multicell organisms, and then animals, and even eventually in human cells. In the laboratory, the CRISPR tool consists of two main parts: a guide RNA and a DNA cutting enzyme, which is most commonly called Cas9, CAS9. Scientists designed the guide RNA to mirror the DNA of the gene to be edited, called the target. The guide RNA then partners with Cas and, true to its name, leads Cas to the target. When the guide RNA matches up with the target's DNA, the Cas then cuts that DNA. What happens next depends on the type of CRISPR tool being used. In some cases, the target gene's DNA is scrambled while it's repaired, and the gene is inactivated. In other versions of CRISPR, scientists can manipulate genes in more precise ways, such as adding a new segment of DNA or editing single DNA bases. Scientists have used CRISPR to detect specific antigens, such as DNA from cancer-causing viruses and RNA from cancer cells. So it potentially has a utility as a diagnostic tool as well. The first human trial in the U.S. to test a CRISPR-made cancer therapy was launched in 2019 at the University of Pennsylvania. The study, which was funded largely by the NCI, was testing a type of immunotherapy in which patients' own immune cells are genetically modified to better see or target and kill the cancer. The therapy involves making 4 genetic modifications to T cells, which are immune cells that can kill cancer. First, the addition of a synthetic gene gives the T cells a claw-like protein, sometimes called a receptor, that sees a target called NY-ESO1. It's a molecule on some cancer cells. Here's where CRISPR comes in. It's used to remove the 3 genes, 2 that can interfere with the NY-ESO1 receptor, and another that limits the cell's cancer-killing abilities. The finished product, which is dubbed NYCE T cells, were then grown in large numbers and then given back to the patients. Those manipulated T cells then find and kill the cancer cells in the patient, which carry that marker. As I mentioned before, we've tried other ways of altering or editing genes previously, but they've been very tedious, very time consuming, and very expensive. They're not really practical. As I said, I've done some of those studies myself, and I'll quote one of them here. The big advantage of CRISPR is that it's much easier, quicker, and reliable. Basically, a high school kid could set up a lab in his bedroom and utilize the CRISPR technique. It's almost that easy. To quote Dr. Jerry Lee, MD, PhD of the NCI's Division of Cancer Biology, Dr. Lee said, CRISPR is becoming a mainstream methodology used in many cancer biology studies because of the convenience of the technique. And as I mentioned, there are several human trials currently using CRISPR in some form or fashion. So I would encourage anyone who's currently struggling with cancer to see if you might be eligible for that kind of trial. And continue to be watching here and other places because we're going to hear more about this technique in the next few years for cancer. And I'm very enthusiastic about it. I think this has the potential to really improve cancer therapy.
Drive me home, la, la. I want you to rock me, mama, just like a Cadillac over. Come on, Joe.
As I said, this is a holiday week, and we've been with the kids and the grandkids a lot and traveling. So the only live music I've had a chance to see what happened yesterday, last night, Saturday night, at the Ullman Stadium in New Orleans before the Tulane Charlotte football game. So here you go. That's about all we have for now. As I mentioned, we are on the road today at our New Orleans office. The doctor will be back in the office in Orange Beach next week for another episode of the Blues Doctor Recommends. So we'll invite you to tune in again then. So, as I usually say at this point, please watch next week's podcast. Okay? See you later.